Welcome to today's session. In this video, we'll explore the concept of data flows in Azure Data Factory, a powerful, visually designed data transformation tool. Master industry-ready skills effortlessly with our channel, covering Python, free AI tools, data engineering, generative AI, cloud fundamentals, and more, perfect for beginners, researchers, academics, and professionals. Subscribe now, hit like, and share with your friends and colleagues to stay ahead in the AI revolution. When discussing data analytics and business intelligence, the term ETL is commonly used. Azure Data Factory is built around this principle, and data flows enable seamless data transformation within it. The best part? No coding is required. Data engineers can develop transformation logic using a drag-and-drop interface, making it an intuitive and efficient way to process data. This is a key advantage of this approach, simplifying complex transformations through a graphical user interface. Today, we'll walk through a hands-on demonstration. We have a CSV file stored in an Azure Storage account, which contains unclean data. We'll perform transformations, such as merging to columns, selecting only relevant fields. Finally, we'll store the clean data in a new folder within the storage blob. Throughout the session, we'll also see how data flows integrate seamlessly into ADF pipelines, allowing efficient execution within your data workflows. Here we are in our Azure portal. Let us move ahead to the storage account. Click on Data Storage and then on Container. Currently, we are in the storage account, where we can view the available container. Within these containers, there are two folders, raw data and processed data. There are two CSV source files in raw data, product and sales data. Let me demonstrate using the product file. Click the Edit tab to see the CSV file. This product file has various fields like name, category name, parent brand, cost price, and tax. The transformation we aim to perform involves combining the category name and parent brand fields into a new column named New Category Name, ignoring the tax column, retaining the column's name, new category name, brand, and cost price as the final output. Close this file. Let us now click Open the Processed Data folder. The folder does not have any CSV file currently. It will store the file after processing is done. Now we are inside our Azure Data Factory. These are the source data sets and the destination data sets that we have created in our earlier tutorial for the copy data activity. Let us now follow the best practice and rename these dataset properly so that we can recognize them easily. Delimited text 1 is renamed as product_src, where src is the source data. The second file, delimited text 2, has been renamed to sales data_src under the General tab. This renaming can be performed in two ways: using the three-dot menu as demonstrated earlier, and also by renaming it directly under the General tab as shown now. Both methods achieve the same result. Now let us rename the target datasets. The Azure SQL Table 1 is renamed as product_SQL_TRGT, where TRGT stands for target. While the Azure SQL Table 2 is renamed as sales data_SQL_TRGT, where TRGT has the same meaning as before. So now we have all our data sets renamed and we can identify them easily. Let's navigate to Data Factory. Now, let's create a new data flow. To do this, click on New Data Flow. This is the graph area. This is where the data flow is visually represented. This is the parameters area. This displays configurable settings for the selected components. Let's add a source. In this case, source is the dataset named product_src. Click on Add Source. Select the source dataset from drop-down, which is product_src. Let the rest of the options be default ones. There are other configuration options like source options, projection, in which you can see all the column names are displayed for the source dataset. Other configuration options like optimize, inspect and data preview are also there. We will retain the default options for now in each case. At each step in the data flow, you will notice a plus symbol, allowing you to add the next transformation. Upon clicking the plus symbol, you can choose from various transformations such as join, derived column, select, aggregate, surrogate key, filters and sort, and sync for final data loading. These are the available transformations in data flow. For now, we will proceed with a derived column transformation to keep it simple. Here, we will add a new column as part of the transformation. Now, let's rename the newly added column to new_category. Here we have to provide the expression. Expressions define how data is transformed. If you are familiar with the syntax, you can write the expression directly. Otherwise, you can use the expression builder to assist you. Click on Open Expression Builder. Select the columns to concatenate. Here, category name and parent brand. Use either the plus operator symbol to concatenate them. To clearly differentiate between the two values, add a hyphen in between and click Save and Finish. Now, we will apply another transformation, Select, to retain only the necessary columns and remove unwanted ones. After adding a Select transformation, deselect any columns that are not required. Select Tax as we have planned to remove it. Select parent brand and category name since they were already combined into new_category. Let us now delete them one by one. The remaining columns are name, cost price, and new_category. As seen on your screen, the number of columns are now reduced to 3. Now that all necessary transformations are complete, we can proceed to the destination, which is the sink in data flow. For sink, we need to create a target dataset where we will store the clean data. This time, it will be another delimited dataset. Select Azure Data Lake Storage Gen 2 and then select delimited text. Let us rename the target dataset here itself as product_processed and then select the linked service we have created already. Provide the path of the destination folder by clicking the folder icon. Select Mind Alchemy Data followed by the folder Processed Data. Click OK. Here is the path set now. Again click OK. So now let us select the sync dataset. Here is our product_processed, which is now selected. We will now click Publish All first to save the configurations. Click on Publish. The entire setup is now getting deployed. Now we will create a new pipeline where we will call the newly created data flow. Under Activities, you can now see the data flow activity. Drag it to the pipeline. We will leave all other parameters as default for now. Let us now select our data flow from the drop-down. As a part of best practice, let us rename it as Product Data Flow. Let us also rename the pipeline as dataflow_pipeline. Let's proceed with running everything in debug mode. Please note that this process may take some time. The clusters are now starting in debug mode. Before initiating the debug process, we need to start the data flow debug first. Now the actual data flow execution will begin. While the dataset is relatively small, the execution time can be significant. The execution is currently in progress, and the system is actively processing the required operations. Once the execution is complete, we can verify the results to confirm successful completion. The successful execution indicates that all components are correctly integrated and operating smoothly. Now that the data flow debug is completed, let us go back to our pipeline. Let us click Debug here in the pipeline. Let's monitor the progress. The status currently shows queued, meaning the process is waiting to be executed on the server and cluster. Now the status has changed to In Progress, which signifies that the operations are being executed. The system is actively processing the data flow, transferring information between the specified storage locations. Once the process is complete, we will verify the final output to ensure successful execution. The process is now complete. We can check the output now in the storage. Click the Processed Data folder. Here is our output file. The output includes 3 columns: name, category, and cost price. Additionally, the category and brand columns have been successfully combined into a single column. This confirms that we have achieved the intended transformation efficiently. If you found this tutorial valuable, don't forget to subscribe to the channel, like the video, leave a comment with your thoughts or questions, and share it with others who might benefit. Explore the description for a link to our Udemy course, where you'll learn techniques to use generative AI to automate your daily tasks. Also, check out this YouTube channel for more videos covering Python, data engineering, ETL, cloud computing, generative AI, and much more. See you in the next video.